of traditional flight controls with the reliability and maintainability of fly-by-wire. This program will introduce you to flight control mechanisms for the Boeing 777. In Part 1, we will see components related to roll control. In Part 2, we will see yaw control components. And in Part 3, we will see components used for pitch control. To see things more clearly, we will be looking at the 777 flight control test rig. Any component you see painted yellow or connected with orange wiring is test equipment. It will not be in the actual airplane. Part 1. Roll control. The control wheels control the ailerons, flaperons, and spoilers. Turning the captain's control wheel moves the control cables to the cable drum on the left lateral control mechanism. This operates the wheel force transducer. The wheel force transducer has two functions. It supplies electrical signals to the bank angle protection function and connects the left wheel drum to the left crank, which moves the left shaft assembly. The feel and centering mechanism supplies artificial feel forces and centering. The aileron trim actuator supplies roll trim. The aileron trim switches let the pilots adjust roll trim. Note, aileron trim is shown at the top of each control column. Moving the aileron trim switches causes the aileron trim actuator to move the feel and centering mechanism. The back drive actuator moves the control wheels to match autopilot commands. The control wheel damper removes oscillations during control wheel movement. There are 3 wheel position transducers attached to each lateral control mechanism. The wheel position transducers supply wheel position signals for actuator control. Travel stops on the bottom of each shaft assembly keep control wheel movement to a limit of 65 degrees. Two force limiters connect the left lateral control mechanism with the right lateral control mechanism. We'll talk more about these later. The right lateral control mechanism has a cable drum for inputs from the first officer's control wheel. Three wheel position transducers, a back drive actuator, and travel stops, just like the left lateral control mechanism. Two components the right lateral control mechanism has that the left mechanism doesn't are the lost motion device and the forward spoiler quadrant. The lost motion device connects the right cable drum to the right crank after allowing enough play for the force transducer to operate. And the forward spoiler quadrant transmits control mechanism motion aft to the spoiler control mechanism quadrants through a series of idler pulleys and turnbuckles. Before we continue, let's take a closer look at the operation of the force limiters. In normal operation, the force limiters transmit inputs from one control wheel to the lateral control mechanism and control wheel on the other side. If a control wheel does not move freely or a cable connection breaks, the force limiters permit the other control wheel to maintain roll control. Now let's look at the roll control power control units, or PCUs. We'll start with the aileron PCUs. There are two PCUs on each aileron. The aileron PCUs move the ailerons up or down as commanded by the control wheels. In order to manually bypass an aileron PCU for maintenance, you use an Allen wrench to turn the spring-loaded manual bypass. There are two flaperon PCUs for each flaperon. To adjust the flaperon PCU null LVDT, remove this access cover. The adjustment process is almost the same for all primary flight control PCUs, except the spoiler PCUs. Each spoiler has one PCU. During roll maneuvers, the PCUs for spoilers 4 and 11 are controlled by cables from the spoiler control mechanism quadrants. All other spoiler PCUs are electrically controlled. The spoiler PCUs are manually rigged. This ends Part 1. In Part 1, we have seen flight deck controls, forward equipment center components, and power control units for the ailerons, flaperons, and spoilers. Part 2, yaw control. The rudder pedals control the rudder. Rudder pedal position is adjustable by cranks in front of the captain and first officer. Pushing the rudder pedals moves rods connected to the rudder jack shafts under the flight deck. The rudder jack shafts are connected by a bus rod so that one or the other set of pedals can move the rudder control assembly. Each jack shaft assembly also has an output control rod that connects to a shaft assembly. The left shaft assembly has two rudder pedal position transducers. A travel stop, a backdrive actuator for autopilot control, the rudder feel and centering mechanism, the rudder trim actuator, and rudder trim position transducer. The rudder feel and centering mechanism supplies feel and centering to the yaw control system. The rudder trim selector and the rudder trim indicator are on the aft aisle stand. Operating the rudder trim selector moves the neutral position of the rudder and rudder pedals. Pressing the manual trim cancel switch causes the rudder to return to the center position. The right shaft assembly has two rudder pedal position transducers, a travel stop, and a back drive actuator, like the left shaft assembly. The right shaft assembly also has a friction brake and a pedal damper. The friction brake adds resistance, so the fly-by-wire rudder control system feels like a traditional cable-controlled system. The pedal damper absorbs rudder pedal vibrations and helps stop rudder control system movement with minimum oscillation. There are three rudder PCUs. Each rudder PCU operates with hydraulic power from a different hydraulic system. This ends Part 2. In Part 2, we have seen flight deck controls, forward equipment center components, and power control units for the rudder. Part 3, pitch control. There are two types of pitch control: short-term, using the elevators, and long-term, using the stabilizer. We'll look at elevator control first. The control columns control the elevators. Moving a control column forward or aft moves a column torque tube assembly below the flight deck. Each torque tube has a compliance spring, a column force transducer, a lost motion device, a crank for a column damper, a stick shaker actuator, a column balance weight, and a travel stop. The compliance spring connects the column torque tube with the column force transducer. The flexibility of the compliance spring simulates the feel of a mechanical system to the pilots. The column force transducers measure the amount of force that the pilots apply to the control columns. The lost motion devices permit motion in the force transducers while permitting continued control if a transducer fails. The column dampers resist column movement. This prevents vibrations and helps stop column movement with a minimum of oscillation. The stick shaker actuators make the control columns shake when the airplane is near a stall condition. The column balance weights balance the control columns. And the column travel stop keeps control column movement to a limit aft and forward. Each control column torque tube assembly attaches to an elevator feel unit. The elevator feel units supply feel forces to the control columns. They also supply a centering function that returns the control column to neutral. Each elevator feel unit has 3 column position transducers. And an elevator feel actuator. The elevator feel actuators change the geometry of the elevator feel units to change feel forces at the control columns. The breakout mechanism connects the 2 control column assemblies. The breakout mechanism makes it possible to control the elevators if a jam occurs in either pilot's control column mechanism. Two backdrive actuators move the control columns as the autopilot commands. Now let's look at the elevator PCUs. There are 2 for each elevator. The elevator PCUs are electrically controlled and hydraulically activated. Now let's look at stabilizer control. Control the stabilizer with either the pitch trim switches, which control the stabilizer electrically, or the alternate pitch trim levers. The levers operate quadrants in the aisle stand. Cables run aft from the forward quadrants to the alternate pitch trim aft control module in the stabilizer compartment. Here the cable movement changes to control rod movement. As the stabilizer reaches its up or down travel limit, stops on the travel limit drum assembly move the travel limit hammer to its neutral position. This moves the alternate pitch trim control lever to the neutral position and stops the stabilizer command. The control rods from the alternate pitch trim aft control module connect to input cranks on the stabilizer trim control modules, or STCMs. The STCMs control the stabilizer ball screw actuator, which moves the stabilizer. Each STCM has a brake bypass valve button. This button allows maintenance personnel to manually bypass brake release pressure to the secondary brakes on the stabilizer ball screw actuator for testing. This ends Part 3. In Part 3, we have seen the flight deck controls, forward equipment center components, and aft stabilizer compartment components for both short-term and long-term pitch control. This also ends our program. 777